we're going to talk about light waves and electrons. Our learning objective is going to be to describe the mathematical relationship between energy, frequency, and wavelength of light using the electromagnetic spectrum. But let's start by first defining what light is. So light, the stuff that you think of when you think about seeing, is actually a type of energy that is produced by the movement of charged particles. So for example, when electrons move inside an atom, they may produce light that we can see. However, there are actually multiple types of light, and they are all together known as the electromagnetic spectrum. Individually, they can also be called electromagnetic radiation. And the light that we see is actually only a really small part of this spectrum. And the part that we can see we call visible light. But the spectrum includes things from radio waves to X-rays to even gamma rays. And this light travels through space at a constant speed as a wave. And we can describe it the same way that we describe other waves using frequency, wavelength, and energy. So let's start by defining what a frequency is. Frequency is the number of waves that pass a certain point every second. We say a wave is more frequent when there are more waves showing up per second. Another way of saying more frequent is higher frequency. And so here in this picture, you can see the top wave shows up a lot more, almost twice as often as the bottom wave. So this top wave has a higher frequency. The bottom wave has a lower frequency. Now, wavelength is how long a wave is, or the distance between the top of one wave to the top of the next wave. And when we describe wavelength, we can say that a shorter distance between waves is a shorter wavelength. And finally, energy is the amount of energy that the wave carries. And typically, the more frequent the wave, the more energy. If you imagine holding a jump rope between two people and swinging it up and down to make waves, the faster you swing it, the more waves you will make, but also the more energy that it takes. If I want less waves, I can move my hand up and down more slowly. So all three of these descriptions of waves are actually all related to each other mathematically. Frequency and wavelength have an inverse relationship, or they are opposite of each other. When one increases, the other has to decrease. Here, I have a short wave, but it has a very high frequency. There are lots of these waves. The bottom wave is a longer wave, the longer distance between the waves, but the frequency is lower. So they are opposites. Frequency and energy, however, are directly related. It means they move in the same direction. If the frequency increases, then we also say that it has more energy. So high frequency is high energy. Low frequency is low energy. And in this way, we can also say that wavelength and energy are opposites. When the wavelength is short, that means there's high energy. And when the wavelength is long, that means there's low energy. So these are the properties of waves and how we think about waves when we describe them.